Hello and welcome to this edition of Tools for the Craft, Kubernetes development environments. In our today's edition, we are going to talk about what can a Kubernetes development environment look like? How can we create Kubernetes-based development environments for our software developers that create software that runs in the end on Kubernetes. This is Robert and Michael. Hi, Robert.
Hi, Michael.
Where are you at the moment?
Well, currently I'm at home. Of course, I'm in home office. It looks like you're too in your home office. And I'm kind of heading into the weekend, so this is probably the last thing before I'm going to head into weekend.
Wonderful, yeah. I just recently added a new desk to my home office workplace here. It's like super cozy, and I do have much more space, and it feels like a little refresh to my working environment, and it's awesome.
Oh yeah, that sounds nice.
Cool. So you do have experience with Kubernetes-based development environments?
Oh yeah, absolutely. For the last, I don't know, maybe since 2018, I've been working with Kubernetes. And of course started out not knowing anything about it and just getting down and dirty, so to speak of, and kind of learning the hard way, wrestling with kube control and trying to get something working locally. In the beginning, starting to work with Docker Compose and then trying to move the stuff to a staging or production environment in Kubernetes. And over time, more and more learning about local Kubernetes solutions and tools to actually better work and develop my applications natively in Kubernetes.
Yeah, I think that is where most or many developers are at the moment, like working with a Docker Compose setup, because they are developing applications for like a longer life cycle than Kubernetes is actually a thing. And it feels like that running Kubernetes on a local development machine is still not as convenient as it should be. And that Docker Compose comes like much more simple in terms of writing the infrastructure part, creating a database, caching layers, storage, for instance. And I suppose that many developers are going this way, like having a container-based development environment at the moment, with all the ins and outs, and then trying to push their experiences a bit towards working with Kubernetes, which comes with its own complexity, right?
Yeah, absolutely, and it's also something I experienced. I moved on from Docker Compose. I totally get why people work with Docker Compose. It's super convenient. But of course, I want to maintain that prod parity and want to work locally with Kubernetes, because in the end, you're deploying something to staging or production. It doesn't work, and yet again, you're at, well, it worked on my machine with Docker Compose, why doesn't it work? But of course, it can also be a challenge to move my stuff onto other colleagues who aren't that that into the ops part of DevOps. And to me, it's kind of simple, or I'm super interested in that part, and other developers maybe not so much. They just want to develop. And so I totally get why people maybe get stuck on Docker Compose or still use Docker Compose and not actually locally develop with Kubernetes.
Would you describe yourself more like a developer or more like an ops guy or something in between, like DevOps?
Well, it probably kind of depends on which time you are asking me. Sometimes I'm more a developer. I'm having quite development heavy tasks, and sometimes it's more or less strictly ops, where I'm doing just ops tasks. So overall, it's probably DevOps, and kind of depends on the project and the role I'm kind of doing in that project.
But I think this is a very interesting, like a first interesting question is providing like Kubernetes configs and spinning up pods and deployments and stateful sets and so on and so forth. Is this more like a operations activity, or does this has something to do with development, or is operating a Kubernetes cluster as is the operations part? So where would you like draw the line between this is more like a development activity and this is classical ops?
Yeah, it's an interesting question. I don't know if we can arrive at a clear answer. Maybe it depends on the kind of people you work with. For me, I'm absolutely DevOps, maybe with a capital Ops, and I actually come from a history of, well, now we have a virtual machine and gonna install some Nginx, some uWhiskey, whatever, and getting dirty with that and kind of deploying the application there. So I have no problem with all the Kubernetes stuff and can actually work my local Kubernetes cluster. But I get that it is a challenge for some developers, or if you're more on the development side and not so much on the ops side, so maybe you are a DevOps, but with a very capital Dev, that it is kind of a little bit too much, and shouldn't probably not be expected to say, well, you're working now with Kubernetes, now you get to know Kubernetes in depth and kind of need all the stuff on your own. So probably it depends on the people you work with, but I can see a role for the ops person to kind of provide something that makes it easy to spin up the local development, so that you don't actually need to know every tool and every command and every flag you just need to use, or you're copying, well, now run this command and now run that command, and the person does not really know what he or she is doing. So I think that's probably more in the role of ops, in my opinion.
Yeah, it's at the moment, I'd say it's quite difficult, isn't it, to like have some sort of like integrated developer experience working with Kubernetes on the one hand, but writing code on the other hand, like being an expert on writing a certain language or framework as part of the application side, putting this into a well-crafted container image, and then providing all the resources that are required to run this container image in Kubernetes, while having all the attached resources also on the radar, like the database connection or other API services that you're consuming. So it's quite a vertical for people to learn, like lots of layers of additional complexity that goes way beyond writing just an application. But still, I think it's hard to differentiate between the one setting up the Kubernetes cluster, like the data plane and the control plane, and making sure all nodes are up and running and the kubelet interacts properly with the API server and so on and so forth. And then providing actual applications on top of it, which I think it's at least maybe call it gut feeling, but I think that providing the Kubernetes resources is also part of the development team, which is, I think it's difficult. Because from what I saw, we still struggle with writing good, slim, but still debuggable container images, and then add the complexity of Kubernetes to it, which is probably even worse. But calling this development, right?
Yeah, absolutely. You're starting out as a software developer, and well, this is a piece of code. This is the application I want to develop, but actually you're not developing this. But you're stopping there and kind of have to manage all the other parts that you didn't actually start out with. So yeah, it's quite the challenge or it can be quite the challenge to move to Kubernetes and kind of find your way around and how to actually work with it. What parts do you want to learn? There is absolutely a steep learning curve you have to master. And yeah, it can be quite challenging and quite a daunting task to start out with.
Yeah. So let's have a glance at our history at Blue Shoe and our team. How did we come to the point that we are at the moment? We consider ourselves knowledgeable of the Kubernetes parts, right? We do have a few people in our team are actually Kubernetes certified.
Oh yeah.
But and you too. So, well, tell us a bit about our journey. So, how did we get started and where are we now? How did we manage those challenges with working with Kubernetes on our developer side?
Well, yeah, or as I've mentioned earlier, we kind of started around somewhere in 2018, so about 4.5, 5 years ago now, and just started out without knowing anything, without doing any kind of learning or certification in advance or whatever, but just trying to figure out how does this thing work, how can we work with it. Well,
yeah, we call it the hard way, right?
Yeah, it definitely is the hard way. And before that, we actually mostly were using or developing our programs or applications with Vagrant and a little bit of Docker Compose, some Docker images. And I guess, or I think we moved basically all our projects to Docker images when we migrated to Kubernetes. And yeah, for quite some time, it was a little bit of a struggle or of not really knowing how can we really comfortably develop our applications so that they are Kubernetes native, that I, as a local developer or somebody else from our team as a developer, can just develop with Kubernetes, and had quite some projects that were using Docker Compose where we saw all those issues of like, yeah, well, let's just deploy it, tell our customer, well, it's going to be ready tomorrow, we're going to deploy it. Well, nothing works. Why? It worked on my machine. And all the stuff we actually really don't want to do. So somewhere along the line, we started out with K3D. We looked at Minikube, which at that time didn't have the capability to spin up multiple clusters. So you only had one Minikube cluster, which was inconvenient for us as a software agency. We have different customers. We actually want to have different local Kubernetes dev clusters that I can just start and stop however I want. And so we looked at K3D and kind of worked with that and used telepresence to kind of switch our local development container into that cluster, which for a time worked okay. But over time, overall, we weren't really that satisfied with telepresence, especially after they launched telepresence 2. We had quite some issues with that. And
I think we're going to talk about this later on.
Yeah, probably, yes. And so usually our Kubernetes manifests, we used tons of Helm charts and made different experiences with that, and also kind of tried around with Customize, made some experience with that. But that was kind of our journey where we are from our software projects.
Yeah, I think what is important to add is that we do not have like a strong ops background in our team. So we are very focusing the development part, coming from a pure development agency with lots of development capabilities. But then I think we maybe also in 2018, maybe 2017, 2018, we found that our operational setups, usually in the cloud, using virtual machines, became too heterogeneous, right? We had like different VMs, flavors, different operation systems with databases and all those components being deployed into VMs, and like this pet versus kettle analogy, we had a lot of pets. And I think this was also a driving experience for us to decide, okay, this is very, very overwhelming to maintain those operational infrastructures. So let's have a look how we can do things better. And I think we came up with containerizing our software very quickly. That's what you said. We've been using Docker Compose, and then I think it was only consequent to move this also into the cloud. And as an agency, it was always important for us to be portable, to create our infrastructure very portable, and so that our customers can come to us, hey, we found that cloud provider ABC is too expensive. How can we migrate our software? And we did this more than once. I think this is one of the very strong selling points of Kubernetes at all to have it on all major cloud platforms, but also being able to migrate workloads back to the data center in my basement. And so there we had some like multiple incentives to look into Kubernetes, and I think we are not looking back in anger. So
no, absolutely not. I would say the pains of the hard way were totally worth it, because of course we still have diverse requirements from the different applications. We use different databases, managed databases, or hosted databases in the cluster of different kinds, and different caching layers or messaging queues or whatever. But all this runs in Kubernetes, which is just this layer above this all, and every project is managed in the same way. So if you know your way around Kubernetes with, for example, with kube control, you can just drop into any of our projects and kind of find your way around that, or even can help out. I have no idea what this project is, but a colleague runs up to me and says, well, there's something not working, and I can find my way around there without having a lot of a priori knowledge.
Yeah, I think this is like a huge efficiency advantage, having the same, let's say, interface to the operational infrastructure of client A or B and project whatever. It's operated always the same way, and this is for us and our team like one of the major advantages. Yeah, that's cool. So then let's move on to like a little introduction to what a Kubernetes development environment is from your perspective. How would you introduce Kubernetes-based development to somebody who has no clue at all about Kubernetes, and how to set up a Kubernetes-based development environment, maybe on a local machine?
Yeah, of course. I would probably start out by just throwing them into the cold water and deploying a local cluster on their machine. So it's probably starting out would be a quite hands-on task where I'm sitting directly next to them or virtually next to them, and just deploying a local cluster that you need, maybe having a kind of sample application where you can look at the Docker file, how that comes together, the image registry, where that is pushed, look a little bit at some manifests, some Kubernetes manifests, to just see what is going on. We're, for example, we're going to deploy this as part of a deployment in Kubernetes. We're having the image here. This comes from our image registry. We're going to deploy it. We're just going to see what's going on there. Here we can look at a pod that is going to start up. We might want to look at some logs of that pod, or maybe exec into a shell into the pod, to just kind of get this hands-on experience to see this stuff that's actually going on down there. And then we might want to look at how can you actually develop your application and run the application in Kubernetes without the need to, well, I have now code changes, and what do I do now? Do I build an image and push it to the registry and redeploy it? So we kind of want to figure out how does that shortcut actually look like, where you can develop code locally and actually see the changes directly in your cluster without redeploying. So probably that would be my strategy, or my way to kind of take some developer by his or her hand and kind of move that person through this process. But with knowing that this is quite a lot, especially if that person never worked with Kubernetes before or doesn't have really an in-depth knowledge of Kubernetes.
I think to answer a bit about the why do we actually want to make this happen? And I think this adds up a little bit to what we had before, where is the development part and what is DevOps and what is Ops, maybe. And coming back to the why do we want to provide Kubernetes-based development environments is probably because we want our developers to know a bit more about Kubernetes, after all, having them being able to like debug into a online cluster something that is pre-production or even on production systems. But also to keep up this dev prod parity. What does this actually mean?
Well, yeah, I think it can be quite favorable if your developers also know something about the infrastructure part. Not that they can actually do all those tasks. That's where you have your ops or your DevOps people. But to just know what's going on there, have a understanding of those concepts, and not just, well, I developed my code that runs somewhere now just get it to work. And then it's all the work of the ops people or the DevOps people to just try to figure out, well, what is this application actually doing? What does this application need in terms of environmental variables, in terms of what needs to be run, what ports need to be open or whatever, so that we have a closer communication, that the development side knows what the ops side actually needs to know to do their job, to kind of give the specs beforehand. Well, I need a deployment with this, or maybe do I need a stateful set, something that keeps the state, or I need some additional stuff like a task worker. I need some of those ports. I need those environment variables, so that it's not just like separate parts of your company where each part is like, yeah, well, I did my stuff and this person didn't do their stuff, but that everybody knows a little bit more from the other side. And I would say that is quite a huge advantage.
Yeah, good point. And did you ever heard before about the shift left model? That's maybe something related to what you just said.
Yeah. I kind of heard, or I kind of stumbled upon that from time to time. Can you explain it a little bit more?
Yeah, I tried to explain it in one of my recent talks, that shifting left means to look at all the utilities early in the process, like scalability, security, and all those utilities. I like this term. Having the production infrastructure quite close, even available during the time of writing the software, can give a huge advantage in all those aspects of providing software. I mean, it's not just writing code. That's probably a misunderstanding. Developers nowadays are required to also write secure code, or make at least sure that what they are shipping to the users does have some fundamental security aspects baked into the process, into the entire process. And this is probably something that we in the past did like more on the right side. If you like look on the timeline, then you start left with developing your application, testing it, maybe moving it to pre-production systems, and eventually it goes into a production environment. And then somewhere in between of those later parts, you look into something like, okay, how does the security of my application actually look like? This is obviously partly a responsibility of the platform, of course, but still, if you are providing container images that are vulnerable to backdoor attacks or remote code execution, stuff like that, it's a good idea to move those aspects more to the left. And this is probably what the shift left model is all about.
Oh yeah, absolutely. In my head, I'm just thinking about, then we have this shift right model, and we're gonna have a long evening when deploying stuff, and just kind of figure out, well, this doesn't work and that doesn't work. We kind of want to have more of a longer morning and have those pains when starting out, and actually knowing, well, my container doesn't run as root, and now I'm going to run into some issues. I want to figure out those issues very early, and not just when I'm kind of deploying it into a production or pre-production environment.
Yeah, just let's ask ChatGPT what a answer could mean. So the shift left refers to a methodology or approach where the testing and quality assurance activities are moved early in the development cycle. Okay, that's what I just said. Traditionally, testing, quality assurance conducted towards the end of the software development lifecycle. Cool. Yeah, that's also what I said. By shifting testing and quality assurance left in the SDLC, software development lifecycle, developers can identify and fix defects earlier, which can lead to faster delivery of high quality software. I mean, this makes sense, right? If I, in the classical software development theory, it always says, if you find a bug early in the process of developing a software, it's much cheaper than fixing it than if you come up with a bug of a software version that is rolled out to production and maybe, for example, generates data that is just wrong, and you need to fix not just the code but also all the data that code generated in the past. And minimizing the risk of delivering low quality software to the end users. Agile and DevOps is also a term in this context, where the emphasis is on continuous integration, okay, yeah.
Well, ChatGPT is a little bit more crisp and more precise than just talking about it.
Yeah, I just find that everybody's talking about shifting left all the things, and nobody actually knows what this means. And essentially, if you really want to hold on the shift left model, it would probably also mean that your developers should work with Kubernetes after all.
Oh yeah, absolutely. That's totally an argument for that. Keeping dev prod parity and starting out your application as it will be run later on in the production stage. Okay.
Cool. So then let's have a look into how we can actually set up a Kubernetes environment.
Yeah, sure. So I'm just gonna share my terminal. There it is. As I've earlier stated, we kind of started out with Minikube and with K3D, and we might just want to start up a cluster with each of those two. So Minikube has evolved in the last few years and is actually quite popular, and is kind of the recommended.
I think it's the most popular tool.
Oh yeah, and it's also all in the Kubernetes documentation. Every example is like, well, here use Minikube and do this and do that, and we can just start out a new cluster, Minikube start, and we can actually give it a profile to have the capability of having multiple Minikube clusters on my local machine. So I can just use this command with the -p flag. Gonna just start it up. I'm seeing some kind of messages here that Minikube struggles to find a dedicated network. I think that I have too much Docker networks on my machine. But usually this is just a kind of warning, and it works out after all. We have to wait a little while, but it should be here. It should be up and running fairly quickly.
Error.
Here we see another error, but this turns out to be not an error after all. So
don't care about the errors. It's just for entertainment purposes.
Yeah, it's kind of weird that this is reported as an error, because you're like, oh shit, what's going on here? But
to make the process a bit more exciting.
Yeah. This gets my heart rate going. Oh, what's going on? I am putting up control plane. Well, everything's fine. And so it takes a little while. We see now we are done. We got a surfing person. We are actually now in the Minikube cube context, which I can see here. This is called demo, which we just created. And we can just look at the nodes, for example. We see we have one control plane node called demo. That we got with Minikube, and we can just start out our development process and deploy our workloads in here. We can also see our profiles that we have if we want to switch. Well, this is breaking lines, which is not really great, but we can see here we have our demo project, which we just started. We have a Minikube cluster, and we have a test2 cluster from whenever. And Minikube also brings quite some add-ons with it. We can just take a quick glance at them with Minikube add-ons list. We see which add-ons are enabled and which add-ons are disabled. I think actually I am not in the demo context. If we look at Minikube profile list again, or just Minikube profile, I can see I am in the Minikube context where I enabled and disabled different add-ons. So what I would need to do is specify the profile with Minikube profile demo. We can check out the list command.
Oh, that's handy. So you can run multiple clusters while having different sets of add-ons enabled and disabled.
Oh yeah, absolutely.
Okay.
And this is really convenient with all those add-ons. We can look at this add-on list. This is a fresh Minikube cluster. It comes with the storage provisioner and with the default storage class add-ons available. And so just for example, if I want to use the Kubernetes volume snapshots to make snapshots of my persistent volumes, I can see that it is in this list, and I can just use the command Minikube add-ons enable volume snapshots. It takes a little time until it finds this image, maybe downloads it. And I need some more of those add-ons to be enabled and some others to be disabled, which I won't do now, but this is just the general idea. I need to find out which add-ons do I need and which add-ons do I maybe have to disable. I can easily do that, and now I have a cluster, which was my Minikube cluster, which we saw before, where I can use the volume snapshot API of Kubernetes, which is really great and convenient for a local cluster. And so if I don't need my Minikube cluster anymore, I can just say Minikube stop, and it's stopping the node demo. It's powering the node off, and of course after it's finished, to have a clean setup at my laptop, I can just, that's what I want to do, I can just delete the demo cluster. Well, I can't delete it. Oh, I don't need to specify demo. It just takes the profile, but I'm not sure if I can delete it like this. Oh yeah, it deletes now the demo cluster.
I think you can add the -p option and specify demo just as well if you're in another, you have another profile activated.
Yeah. That would be the correct flag. Yeah, of course.
But speaking about your computer, you're working on Linux, right?
Yes, I'm using Ubuntu.
Okay. And what about the performance? How smoothly do this Minikube run on your machine?
Well, I think it's okay. I haven't used it extensively in quite a while, but of course, there is an additional Kubernetes environment running on my machine, and with every other, with Vagrant setups, it was the same issue as well. Some resources go into that virtual machine, be it Vagrant or Kubernetes, whatever. And of course, you may experience some kind of some kind of adverse effects of that. But I'm not under the impression that it is really massive that I just can't use my laptop anymore because I'm running Minikube. So that's at least my experience. Maybe it also depends on the kind of workloads and the size of your cluster, what you're running in there. Of course, you can't just run
of course.
Netflix with all 300 services in there, but just to develop your kind of handful of microservices, it should run fine.
Yeah, and I think in my experience, I'm also working on a Linux platform. It is even better compared to Vagrant, compared to having just a virtual machine that has some fixed resource limits like CPU and memory. Because at least on Linux, you are running like on your native kernel, right? All the processes that go into Kubernetes are running as containers on your local machine, and hence you get a very flexible resource allocation, and it's not static like we had with Vagrant. And and I think this is one of the major downsides having Kubernetes running in Docker, or at least on a container engine on Windows and Mac, because they do still have those VMs in the backend, and they are statically allocated with system resources, which makes it much more unflexible. And at least from what I've heard, the performance is not so great, especially if you like running a few services, a couple of services in Kubernetes, not just like two or three containers, but rather like a database and a front end and an ingress controller and you name it.
Yeah. Let's just say I don't envy Windows and Mac users in that regard.
Okay, so you said K3D in the beginning. Now you showed Minikube. What are the differences? And
well, they are just different technologies. Minikube, I haven't looked into that extensively in the last couple of years, maybe. So I don't know how the resource consumption is with that. As we evaluated those two options in 2018, K3D was much more lightweight. K3D uses K3S under the hood, and they actually they named themselves K3S because they skip 5 of the A's of Kubernetes. Whatever that means, but they are much more lightweight, which is a great advantage running on the local machine. And as a user, well, those are just two different tools. The main advantage for us with K3D was, of course, more lightweight, but the main advantage was being able to run different clusters, which we can now achieve with Minikube. So I actually don't know how they compare regarding resource consumption nowadays. But well, yeah, they're just different tools. Maybe one suits your need better than the other.
Yeah, I think especially if you cannot use K3S for certain reasons. I mean, I can't imagine any reason why I could not use K3S. At least that's from my practical experiences in the past. But I think it's, as you said, it's more lightweight, and therefore you can run it more like swiftly. It's feeling a bit faster, I think. And especially if you're very experienced with working with K3D, you probably won't switch to Minikube after all. But yeah, in the end, it's probably a matter of taste if you're going for Minikube.
Yeah. Maybe Minikube with the add-ons we just saw is more powerful. At least that was my experience working actually with the volume snapshot API, which is not available in K3D, or the CSI driver is not capable, is not providing that. And that's quite easy in Minikube to just say, well, I want to have that available. I need to enable 2 add-ons and disable 2 other add-ons. Maybe there are more cases where you actually figure out, Minikube is quite easy to use because I can enable and disable some add-ons. Maybe, I don't know about that.
Okay. Yeah, I mean, the volume as a snapshot API is probably not of a huge interest for like the average developer. But maybe there are use cases where you're writing very cloud native software that is leveraging those APIs. Then you probably don't have much options or other options than the Minikube.
Yeah. For us, from our experiences where we actually were developing such a feature, it was nice to get a quick proof of concept running. So we have this idea as well, this can work with this volume snapshot API, can't it? And we can just spin up that Minikube cluster, enable add-ons, disable some other add-ons, and kind of see, oh, well, this works. Now it's kind of worth it to try it out on some actually cloud provider. So this was quite nice. But of course, probably those are edge cases in local Kubernetes development.
Okay, yeah. So we can say it's probably doesn't matter which tool you use. I mean, there's Docker Desktop also available. Did you ever work with Docker Desktop's Kubernetes?
No, I didn't. I'm glad I can work natively with Docker, so I don't really see any point in using Docker Desktop with Linux.
Yeah. Yeah, I just recently evaluated a little bit. I installed Docker Desktop on Linux, and as I said, it comes with this VM backend, and they do put up a page on their documentation why it is actually a good idea to follow this approach instead of having Docker Desktop being connected to the local Docker engine that runs natively on your machine. They do have some relatable arguments why this is a good idea, but in the end, I have to say that performance is suffering quite a lot. As I said, you have to allocate static resources for the backend of Docker Desktop. And then they have a Kubernetes distribution, which is fixed to the version they are shipping, with the version being installed of Docker Desktop. And this makes it a bit more unflexible. I think especially if you are running a certain version of Docker Desktop, which comes with Kubernetes in 1.25, but you'd like to run a more production close Kubernetes environment, which is maybe still 1.24 or even 26 already, or 27, then you probably have like this little gap in the API version of Kubernetes, which is maybe not too bad, but still a difference, which can cause very subtle issues that you might have a hard time pinning down.
Yeah, absolutely. You're breaking dev prod parity when you don't use the same Kubernetes versions, and usually should not make that much of a difference. But sometimes the APs from Kubernetes get deprecated and get removed, and you might run into issues in that when you run locally on a different Kubernetes version as in production.
Yeah, we had that in the past.
Yeah, we had that in the past. I actually remembered one cool feature from K3D, which makes it possible to store the configuration. So I am under the impression that K3D is much more configurable. You can actually say, I want to have one server node and 2 or 3 agent nodes available. I can easily set up a port forwarding by just using flags, which can be super helpful when using some tools that maybe switch your local development directly into the cluster and need some ports open for that. And all of this configuration stuff you can just put into a YAML file and share easily to the developers. So I, as an ops guy, would be able to just write down this config file and say, well, you're going to work on project X, and here is the config file. Just run K3D create with that config file, and you have a cluster that is ready to do all those stuff.
Oh, yeah. This is a huge advantage compared to Minikube, which misses such kind of configuration file that bootstraps me everything with a pinned versioning, right? And components or add-ons.
Yeah.
Cool. Yeah. By the way, I will put a blog post that we just recently published on blueshoe.io in the show notes, just along with the tools that we are talking about with Minikube and K3D and of course Docker Desktop. Do you know, just for the sake of completeness, any other tool that we can use to run Kubernetes on a local machine, on a developer machine?
Well, there are some more, although I haven't worked with them. So you might want to use Kind or I think, no, K3D is from Rancher, isn't it? But there are, you stumble upon much more offerings or much more such tools. Although I don't have any experience with those tools. So those maybe those are the more popular ones. I don't know.
I've heard of a K0S at least, although I haven't tried it by now. But maybe it's also like rising very fast, at least from my perception. They are gaining attention, and I think it's probably worth looking into it just as well. I thought that maybe they are following the same approach as the team around K3S does, to put everything into like a single binary and shrinking the size, making a bit more lightweight, especially for development purposes. This is probably a good idea where you have limited resources.
And so they just stripped out the remaining 3 from the 8, whatever that's supposed to mean.
Zero software, zero problems, I suppose.
You run Kubernetes with 0 Kubernetes. Yeah. Well, maybe it's just about the 0 effort or something in that regard.
Mm-hmm. Cool. So then let's head over to some of the best practices that we developed or collected in the past, working with Kubernetes as a developer on a local machine.
Oh yeah, absolutely. So just to quickly interrupt there, my number 0 best practice, because it's actually not a best practice with working with Kubernetes, but the main requirement is develop with Kubernetes locally. Please don't use Docker Compose if you have this running later on in production. So that would be actually my very first, or before the very first. It should not be noted, but of course it is much more easy, or maybe much more easy to develop with Docker Compose. But as we already discussed, this kind of, you probably run into problems later on. So just develop locally with Kubernetes, however you're gonna achieve that. So that would be my number 0. What would be your number 1, or the first one you would start off with?
Yeah, what you just said is like a shift right model, right? You lower the complexity in during the development time and make it very easy and approachable for developers to create all those components and stuff. And then you just push everything on, and then it's probably some poor DevOps guy that just have to make it work in Kubernetes. And having those back and forth with them to say, okay, you just can't store the database connection as part of your source code, for example. Read it from an environment. That's probably one of my first best practices to get used to working with environment variables. This is not specific to Kubernetes at all. I mean, we even had that with Docker Compose, but still I saw quite some source code that was having configuration, like any configuration stored into the source code, which then is packaged and shipped to some execution environment. I think this is a very good best practice and I think it's also part of the 12-factor apps, isn't it?
To use environment variables.
12 factors. Yeah.
Yeah. It is.
I'm gonna have a quick glance at it.
You could also just have asked ChatGPT if he or she or it knows about the 12-factor apps.
I think the 12 factors is very important in modern software development, especially in the web services part or distributed application development. And it says in factor number 3, store config in the environment. So just do it like that. I've heard of Java people writing those property files that are shipped along with the source code, and then selecting the right property file depending on the environment the code runs in. And I think this is like probably one of those anti-patterns to ship the configuration with the code instead of reading it from the environment. And this is talking about this development and DevOps roles. I think this is where it gets mixed up a little bit, because you do have the environment which stores the configuration, and this heavily applies to Kubernetes, where you have like so many configuration parameters stored in the environment, and still having the wish as a developer to being able to steer what kind of configuration my software is now working with. And so it like I depend on something that I might not be in control of.
Mm.
So this basically the whole bunch of the 12 factors app is a best practice that I can recommend to any developer.
Oh yeah, for sure, absolutely.
Writing software that is eventually be executed in Kubernetes. Well, another best practice is to probably select the right tooling, as we just talked about selecting the right Kubernetes distribution like Minikube or K3D and so on and so forth. You will probably have some other best practices or some other tools that support you in your daily work. Like I can name at least tilt.dev or DevSpaces, and of course the tools that our team at Blueshoe is creating, Gfira, that supports you with writing code in a container that is running not within the cluster, but at least it feels as it would run within the cluster, meaning you can spin up any container image with Gfira run, make code changes, and you don't have this build and push and pull cycle that you usually have with Kubernetes. Maybe this is an interesting point. How would you achieve that with any local Kubernetes cluster? I mean, as far as I know, any Kubernetes distribution pulls the container images that are supposed to be run from a container registry. Maybe we can work around this?
Yeah, we can work around this, but in my experience, it's just a little bit cumbersome. So to just kind of get back on to your point, that's also absolutely on my list. Use tools, find tools that suit your need, with which you can work with, that kind of make those tasks easier. You can actually, I think, doesn't K3D have this option to kind of mount images or an image registry into it, where you can just push images to, and you don't have the need to push to Docker Hub or to KIO or whatever. But I would absolutely advise find something that makes a shortcut through that. So, for example, like you've mentioned, Gfira, which we develop, which makes it very easy because you don't really have to build this image and think about where do I need to push this image or where do I mount something into my cluster, but can just use Gfira and say, well, Gfira, run this image and kind of mount this directory where my source code is at, and activate my code auto reloading and just develop natively in that, or it feels like I'm developing natively in that cluster. So that would absolutely be my best practice. Don't really try to figure out, if that's your thing, of course, just do it, go for it. But don't really try to figure out how to do it, the hard part, and use a tool which accomplishes this task much more easier for you.
Yeah. K3D allows you to have a shared container registry from which you can pull into from your local host, from your local machine, and which is then also being served from within the Kubernetes cluster, the K3D cluster. And this allows you to like build on a command line or with Docker Desktop, build a container image, push it into this local registry, and have K3D pull it from that local registry. This spares you at least from uploading your container image into the internet, and also saves some bandwidth. But it still takes some time, of course. And then there's another option with K3D and with Minikube just as well. You can load or like insert container images into the Kubernetes nodes local image cache. So import, that's what I wanted to say. You can import container images into the cluster, which bypasses the way of a container registry entirely and is even more faster. But I think it's at least a bit with a grain of salt that you have to specify the image pull policy with never. And this is like probably something that you will have Kubernetes configs that only work on your local machine with this pull policy. So it means you would probably have to either change it after you applied some predefined Kubernetes configs on your local machine, or you have dedicated Kubernetes configs for this local development. And this is then probably another anti-pattern that you're going to introduce, right?
Yeah, I'd rather have the manifests as equal as possible throughout all my environments, be it production or staging or development. Of course, some things you just can't do on a local development, or you may need to work around that. But for a task like I want to have my code available in my cluster, there are other solutions where you don't need to actually modify your manifests. So I would rather prefer those.
Yeah. And then there's, which I just recently found out with Docker Desktop, they did some very clever thing. They are sharing their container runtime of Kubernetes with your local, with the Docker engine that you're running with Docker Desktop. And that means you can just build a local container image, and without importing it or pushing it to some local shared container registry, you can make this image run within Kubernetes. Still by specifying the image pull policy never, but it's even faster, which would be like great if we could use it on Linux just as well, if we didn't have those performance issues. Yeah. But I think this is a very clever idea to make this process even faster. I mean, with Gfira, we try to prevent anyone from building the container image in the first place. So having the code that runs in this current image as it would run in a cluster without moving any image data back and forth. But if you, for some certain reason, not want to use Gfira, then you are deemed to at least push or build a container image and move it into your cluster in any case. Yeah.
Of course, I'm biased, so I want to use Gfira to have that available. But it just shows you, we talked about a bunch of different ways that this is really or must be a huge topic, because everybody is kind of developing its solution for their technology. And so absolutely there is a need for such a tool.
Cool. Do you have some other tips for troubleshooting, like common issues in Kubernetes or working with applications?
There's also tools with that. So starting out with Kubernetes, you maybe deploy your application, or you know how to deploy your application. You maybe know your URL where you can reach it locally, and it just doesn't work. That's the way it goes often. And so you kind of need to know where to look to actually debug your application. And the hard way would be to learn how to look into all those stuff with kube control. Just how can I look into logs of a container, of a pod? How can I maybe describe this pod to see what is going on there? How can I drop into a shell into that pod? And this can be quite a lot. And so luckily there's something like the Kubernetes dashboard, which can just be deployed and where you can click through. And actually, I think if you're using a Google Kubernetes cluster, you kind of have that dashboard already available in the cloud. And just click your way through that and see the logs of your container. And with a click of your mouse button, you can drop into a shell, which is really convenient. For my part, I know my way around kube control, and at least I am of the opinion that I'm much more quicker using kube control than spinning up a UI and clicking around there. I actually like using kube control, and there are tools for that too. So I like to use K9s, which is spelled with a 9, so K9S, of course.
So it's one more than Kates and
yeah, probably. Well, naming things. And of course, you have K9, you have a dog with, dogs are always great if you ask me. But K9 is absolutely my tool of choice here. We might, or I can show it later on how it actually works. You use it in your terminal, and kind of navigate much more quicker through all pods. And with just a simple command, you can look into logs or you can drop into a shell there. So that would also be another tip, another best practice for me. Use tools for that so that you don't have to go the actually hard way. use the Kubernetes dashboard or something like K9s, whatever suits your need.
Yeah, I think the Kubernetes dashboard is a very underestimated part of the Kubernetes development effort. I think it's because you have to deploy it manually. I think with Minikube, actually, you can just enable it as a add-on. Which should be very easy.
Maybe it's just another.
We can have a look into if you would like.
Yeah, I can just share my terminal again here. And I think, if I'm not mistaken, is there an autocomplete? Ooh, this doesn't look like. Maybe there's just a dashboard command, wasn't there? Yeah, there's the dashboard subcommand.
Oh, it's not a add-on. It's a top-level command.
Yeah. So you can just use it as a command, and I think it just runs the dashboard and gives you the domain or the IP address of the port on your local host where it's running, and just like that, you have the dashboard available, which of course is convenient. Otherwise, you need a way, or you need to deploy it manually. And I'm just too lazy for that, or it's just too cumbersome, whatever. I know my way around kube control. And so that's that. But of course, I know that this is not the experience of every developer, and not everybody wants to just know everything about Kubernetes and how can I achieve this with kube control. But no, I want to look at logs of my application. How can I do that? Yeah, use the dashboard.
Yeah. I mean, the dashboard is very handy, and I personally like it because you can get a lot of information at a glance, and you can navigate through it with using your pointer, and drop into an shell, for example, into any container, and read the logs, and everything is very clean. And so I think it's a proper solution for developers approaching Kubernetes maybe for the first time, as there are some terms like what is a pod, what is a deployment, what is a stateful set, config maps, and so on and so forth. And you have a very clear overview of those components. And I think with it, you have at least some track how to navigate through the cluster and through its components. And I think it helps a lot.
Oh yeah, absolutely.
So for anybody who doesn't know the Kubernetes dashboard, have a glance.
Yeah, definitely.
And then there's K9S, or it's.
Oh yeah. I'm heavily using K9S, K9s.
Okay.
K9s. We can just. I have a cluster available here. I have it installed. We can just drop in there. We see here the overview of all pods they're running. I've installed an Ingress controller, I see, and there's some kube system pods, and I can just switch between deployments, or maybe I want to look at stateful sets. There are none. Maybe I want to look at my nodes. Maybe I want to go at my pods, and just with a keystroke, I can look into the logs. There's nothing going on in this thing here. Or with another keystroke, I can drop into a shell, giving much more convenience for me. I am accustomed, and I like using kube control directly on my terminal. Don't have to switch into a browser and navigate my mouse around that.
Of course.
And with K9s, I don't have to actually type out the commands or with autocomplete. So I can just navigate around the overview and work with everything I need to work with.
Yeah, this looks like a good alternative if you are used to working with terminals.
Yeah, absolutely. This is probably, we get split into two parts: those that like to work with graphical interfaces, and those that like to.
But we don't have anyone representing the graphical interface people here in this conversation.
Well, so terminal wins.
Nice.
So I've actually prepared a little application where we can just quickly look at troubleshooting. As we've just seen, is this cluster where not much is going on. I have prepared, it should be here, our Hello Engine X example, which is somewhere on the Chivira homepage in one of those examples. We can quickly look at that. We have a deployment that is going to be deployed. We have an ingress, and we should have a service somewhere. It's up here. We don't want to look into much detail here. I'm just gonna kubectl apply this file. And I see the service and the ingress were actually applied before. They are unchanged, but the deployment is created. And now I'm just gonna use the kubectl to get my deployments. This is taking a little bit, but here we see our Hello Nginx demo deployment, which we just saw in the manifest, and we see it's not ready. 18 seconds. I know this is an Nginx container, a plain Nginx container, which should spin up fairly quickly. So I'm quite suspicious. I might want to look into kubectl get pods. And I see here is an error image pull. Which
this is exactly as planned, isn't it?
Yeah, probably this is not what I was intending, but I think it's still in there. We can look at our YAML again, or we can actually look at describe pod and our Hello Nginx pod. We can see what the events that are happening in Kubernetes tell us about this pod. And of course, it's saying an error pullback off, image pullback off.
It says
pulling Nginx demos chow. So probably
doesn't exist.
Maybe if we want to deploy a Hello Nginx, chow is the mistake here. So we get back into our template and see here's the chow. So somebody messed up there. Blame your ops guy. We're gonna apply this again with kubectl apply this file. Our
Put some pressure on your ops
be
teams.
updated. It is configured.
Always a good idea.
We can look at our pods again. And we can see our pod here, which is actually completed, which is, of course, not what we want. We want to have our Nginx running here. We might want to look at the logs, or first of all, we describe the pod. And we see there are no more events. It was back off restarting failed container, but nothing new going on here. And now we can just kind of look at the logs. The command is kubectl logs and the pod name. And maybe we see something. Oh yeah, we just see TGIF, I'm out. That's not what we want from our Nginx server. Of course, this is a very constructed example. The command is something I've added here. If we look into the Docker file, it actually comes with a command, so we don't need this command. I'm gonna remove it.
But this is another best practice, but more. This is another best practice more for the part of writing container images, but always providing a default CMD is something that we in the past at least had some troubles with, that our container images did not provide a default command, and doing so will probably spare you from some troubles.
Yeah, probably. So we look at our pod again, and now it's running, and now we can actually see, if we look at the deployments, that it should be ready with 1 and 1. And of course, this was a very constructed example, but those is just the kind of stuff that can go wrong. Of course, if you mess up your manifests, it's more on the ops side that messed up there. But describing a pod and looking into logs of a pod, or maybe executing some command, dropping into a shell, is definitely what, as a developer, you want to do to find out what is your application actually doing there. Is just something missing? Is it not running because we're missing an environment variable? Is something not working out as you intended? That's kind of I think the bare necessities that you have to know your way around kubectl, or maybe the Kubernetes dashboard, to debug your application and find out what's going on.
Yeah. And now you just did shove the writing the Kubernetes configs to the ops guys. It's not that clear, isn't it? I mean, it could also be part of the dev side.
Yeah, it could be. It could be. Of course, yeah. That's kind of where we started out. Where is the line actually drawn? I probably was thinking about a dev who doesn't really have much experience with Kubernetes, who maybe just starts out, or maybe you have really a dedicated ops team, DevOps team, and a dedicated dev team, where you don't want to say, well, you devs now absolutely need to write manifests. But yeah, of course, this could also be the job of a developer to just get this manifest going and then give it to your ops guy, and the ops guy, the ops person, is responsible to get it actually running in staging and production.
Yeah, maybe we should make another episode just making the role description straight. What is the responsibility of a developer working with Kubernetes, DevOps and Ops just as well, to find out maybe how we could organize this, and if what belongs to what role.
Yeah, absolutely. We're coming back to that.
Would be interesting.
Quite in every topic, I have the feeling. So there's probably something to talk about there. In our experience, it was just the implicit decision, or we found out implicit, but of course using Python, and there's the Pythonic way, explicit is better than implicit. So we can absolutely talk about that. It would be interesting to find out where we stand and what we are going to find out and dictate to the rest of the world, who then needs to adhere to our principles.
Yeah, well, this is what thought leadership is all about. To make a opinion and then push it to all the channels that are open for it.
Did you just say leadership or leadership?
Thought leadership.
I understood leadership, but
well, let's move on. We do have one. We do have one remaining topic. I'd like to talk just a minute about remote Kubernetes development clusters, because this could also be a way that you organize your Kubernetes-based development environment. And we are also working on software that makes this even more convenient. But maybe we could just start with the reason why this could be a good idea.
Yeah, I'd like to talk an hour about this, but let's keep it short for this episode. Why would that be a good idea? We kind of had it before. Do I want to use Minikube or K3D on my local machine? Am I running on Linux or Windows or Mac, and do I have to use different stuff? And maybe if I use Docker Desktop on Mac and have 5 or 6 microservices I'm working on, my machine isn't really usable anymore. So I maybe just want to use a remote cluster which runs somewhere in the cloud. I don't even care. It was set up for me as a developer. I just get access to it, a kube config, where it's like, hey, here you go, there's your cluster, and just run it. And I don't really need resources on my local machine to work with Kubernetes and to work with Kubernetes at any scale. If needed, I might even deploy some super large or the complete project in there to maybe have some integration tests or some large scale manual tests going on there. And so I guess those would be some very good reasons to actually why you want to work with remote Kubernetes dev clusters. Yeah,
resource constraints. But there is another reason that I think is worth mentioning. If we have a remote Kubernetes environment, it saves our developers from working with all those tools that we just talked about, right? If setting up Minikube or K3D the right way is something that a developer doesn't need to do if there is a maybe pre-provisioned remote Kubernetes cluster available. And I saw a few teams already to create one development cluster with keeping all the data, databases and volumes and everything, and then having a cluster separated by namespaces, each per developer, right, to deploy an application into their dedicated namespace, test their application in a real Kubernetes-based environment. And just once they are sure that their code is working, they can commit and push and work the code through the CI/CD pipeline.
Yeah, that's definitely neat. Maybe, or what I'm just thinking about, if you're not actually a large company, or if you need to look at finances, of course that can be a decision against or remote clusters, because you need to run a Kubernetes cluster somewhere in the cloud, which can be somewhat expensive if 5 developers are working on this and everybody needs their own namespace or multiple namespaces, because I have 3 projects that I'm working on, and so does everybody else. And all of a sudden we have some 15, 20, 30 namespaces in there and running multiple hundreds of euros or dollars per month just for the setup. This might be an argument against it, but maybe there are solutions that can mitigate those problems. And of course, if you are getting up in scale, those probably are not is not on a scale of cost, which is actually relevant and is buying you a lot of convenience probably.
Yeah, but then I think what is becoming more important is accessibility and having the access privileges. Creating a shared cluster in a larger enterprise is probably more a problem because of providing access for developers to that shared development environment and controlling the access and the data that flows around. And I mean, that's probably then a plus for the local development, which is much easier to organize, at least from a organizational perspective. But of course, you will run into the resource limitations, and then it's cheaper to equip your developers with like massive development machines and have them deploy everything locally, compared to granting access to some sort of cloud-based development environment.
Yeah, maybe. Well, probably the question with costs is really difficult to answer, because you need people that maintain this or maintain that, or people that teach your developers how to use those tools locally, and they run into problems there, and how can you actually help them? And there are advantages and disadvantages on both sides, I guess. But I'm actually quite a fan of remote Kubernetes clusters, or I think there's quite the potential in there. Of course, I'm biased in that, but our tools GetDeck and Bywood, which we develop, kind of go in that direction. And actually, a new feature we are developing, why we were playing around with those volume snapshot APIs, is to have kind of clusters on or off the shelf, where I can say, well, I have your dev cluster already set up, everything you need is installed, or maybe I develop a feature and everything is installed, and I can just transfer this somehow to you. And if you don't need it, you can just stop your cluster or delete your cluster, but the kind of snapshot or the shelf is actually stored somewhere, so it's not producing any cost. So this really mitigates the cost factor. But yeah, I'm biased towards our tools, of course.
Yeah, and the cool thing about GetDeck Bywood is that developers get a dedicated Kubernetes cluster, so you don't have to like organize or manage the cluster and the access of shared resources, because every developer has their own specific Kubernetes cluster with all dedicated resources in there. But it's still running in the cloud, so it sounds like the best of both worlds.
Yeah.
And you don't even have to grant your developers access to the underlying infrastructure, because with Bywood you will get a REST API to create a cluster you just need a token, basically, which grants you the privileges to call the REST API, which spins up a virtual cluster on top of your host cluster, and then creates a tunnel connection to your local machine, so that it feels like the cluster would run on your local machine while being running in the cloud somewhere else on dedicated infrastructure. And I think this is a huge advantage since you don't have to provide the access to the host cluster, to the actual Kubernetes cluster that is running, to your developers.
Yes, absolutely. So there are definitely lots of advantages in there. And to me, or from a developer's kind of perspective, point of view, it just feels like my local cluster or like a staging cluster, but actually my laptop sees that it does not feel like a local cluster because it's not running hot. And it's just convenient. So I don't really need to manage a lot of stuff if somebody provides me just with the kubeconfig and says, well, there you go, there's your development cluster, and I'm ready to start and ready to develop.
Cool. Yeah, I think we will have a closer look into it in one of the upcoming episodes, because we think this is really a tool for the craft to create Kubernetes-based applications with remote Kubernetes development environments. So to wrap everything up, I think we talked a lot about local solutions that allow you to run local Kubernetes clusters. We looked into some of those important tools and tips for troubleshooting common issues in Kubernetes. And thank you, Robert. Thank you very much. And if you do have any questions, then please drop us a comment below in the comment section. I will link everything in the show notes. And if you have anything to add to this topic, then we would be very happy if you get in touch with the team at blueshoe.io. And looking forward to the next session with you, Robert.
Yeah, me too. And just remember, Kubernetes should be easy. It can be easy to work with.
Wonderful. So then see you next time. Take care.
See you. Bye.